So welcome to NX for Manufacturing Tech Tips. Today's tech tip explores how to take full control of feature-based machining using the Machining Knowledge Editor. Demonstration will last approximately 20 minutes. We'll stay on the line, open up the chat window for questions and answers. With that, I'll turn it over to Tom. Welcome, Tom.
Thank you, Derek. Welcome, everybody. Welcome back. In this last session on feature-based machining, we'll talk predominantly and especially show the Machining Knowledge Editor. Before we get into the details, one important piece of information up front. We definitely consider this an admin application, right? So if you followed the first two sessions, you will have seen how end users use this, and this is definitely a part, the Machining Knowledge Editor, which is an admin job where probably a single expert or a small group of experts within your company configure how feature-based machining works. Where do you find it? You start it from your start menu under Siemens, whatever version you have, Manufacturing Machining Knowledge Editor. And you'll see me use it in a minute. There's actually 3 commands in the NX feature-based set of functions that rely on information that comes from the Machining Knowledge Editor. The first action that you may be aware of is you can use the Find Features command, and if you do that, you get a dialog with known feature types. And you may be wondering, where are those feature types stored? Is there a file somewhere? And the answer is yes. They're stored in an XML file which you manipulate using the Machining Knowledge Editor, and I'll show you that in a minute. So when you start the Machining Knowledge Editor, open such an XML file and look at the Feature Recognition tab, you will see the same information that you get presented when you run the Find Features command. So now you know that whatever we configure here is available in the NX session. That same command, Find Features, has an option that I will use in the demo in a minute, which is called Feature Mapping. And feature mapping rules, and I'll create one for you, are actually also created and managed in the Machining Knowledge Editor under the Feature Mapping tab. And last but not least, if we have features and then we use the Create Feature Process command, we'll get a dialog which shows all the available best practice machining rules that you have configured. And if you open up the Machining Knowledge Editor and look at the Machining Knowledge tab, you'll see the exact same set of libraries there that your user can pick from. So these are the 3 usages of data stored in the Machining Knowledge Editor, and we'll show how to work with that and how to manipulate that. So with that, let me stop sharing, share my screen, and I'll start with just running the very basic steps one more time. And contrary to the first 2 sessions, I'm going to use a very, very simple part today, because I'm really going to focus on how to use the Machining Knowledge Editor and to change things. So I'm keeping the demo as simple as possible so we can really see the change and we don't get lost in all the details of a complex part. So just a quick recap on the feature-based machining workflow. The first step is the Find Features, showing us the library of feature types that are available, and we can go find them and end up with a bunch of machining features. And the second step that we've seen before is the Create Feature Process command. If we go back to the Operation Navigator briefly, you'll see there's no operations yet, no geometry objects. And if I select my features, run the Create Feature Process, use the out-of-the-box mill drill library, I get some information window displayed, and that will run through my best practice machining rules, assign operations, assign geometry, select tools, and in the end, for my part, I will have a bunch of operations for the different pockets, just rough them. For the small step hole, spot drill and drill, and for the larger step 1 hole, spot drill, drill, and make it a little bit bigger, right? And that's what we've seen in earlier sessions, and I'm now going to use the machining knowledge editor to go and customize some of that. Before I do that, I want to make one important comment. I'll do the create feature process one more time, and you see this information window. I've used it to show you what's happening, and I'll use it again. By default, if you've installed NX, that window will not show up. And that's because we don't want to show the end user all this detail. But if you're changing the machining knowledge editor, if you're adding rules, changing rules, you would really like to see that window. So go to Utilities, Customer Defaults, look at manufacturing geometry, look at the features, and then find this top entry, Display Information. Make sure that's toggled on, and restart NX, and then from that point on, we'll actually have the information window that we'll need. So I've deleted my operations, I've deleted my features, and I'm really going to get started. And the first thing I want to do is show you in detail something that I did in my very first demo 3 sessions ago, and that was do feature recognition, but this yellow hole that I have here, actually I want that to be recognized as a threaded hole. And at the moment you'll notice that I have no possibility to map features because there's no knowledge there. And if I run the recognition, you will see that that is a regular step 1 hole. It's not a threaded hole, and I want it to be a threaded hole. So what we're going to do is we're going to switch to the machining knowledge editor. I already started it. I'm going to open the default machining knowledge.xml file that comes with the NX installation, and I'm going to make all my changes in that file. At the end of the session, I'm going to show you what else you can do there. We're going to start, as I mentioned, with feature mapping, and going into the feature mapping area, you will see nothing there. So what I would like to do is create a new mapping rule, one of them. I can give it a name, so maybe map test. That's my rule. My recognition will typically find a step 1 hole, as we just saw. There it is, and I want to change that into a step 1 hole with thread. I can pick it from the list. I use the F8 key to bring up the whole list, or I can just type. And that's the basic entry that I need for a mapping rule. I recognize a step 1 hole. I want to change it into a step 1 hole thread under certain conditions. I only want to do this if my recognized features color equals 6. And that's actually, if we go briefly to the next session, if I pick the face that I'm interested in and I do object display, it's a yellow face and it has the number 6. So normally if I would recognize the feature, it would have a color 6. And for me now, in my new mapping rule, a color 6 means I want to change my regular step 1 hole into a step 1 hole thread. And I'm going to add some conditions. I'm going to say my hole is 10 millimeters. I know that. So if my more worked feature diameter 1 equals 10, then I want my recognition, sorry, I made a user error. I want my my pitch to be 1.5. This is metric. I hope most of you know metric. Anyway, I can do that in any unit system. I can now copy that and say, well, if I have a 6 millimeter hole, then I want to have a pitch of 1, and if I have an 8 millimeter hole, maybe I want to have a pitch of 1.25, right? So I can add some conditions based on what else I want to do. There's a few more things I need to do. I need, for instance, to set the thread depth, and maybe or the thread length, actually. Maybe I want to put that and make it identical to the feature depth that I found, and so on and so forth. I actually have most of the conditions predefined that I need, not to waste too much time, so I'm going to copy those from my notes, paste them in, and this one's double, so I don't need that anymore. Let's review that briefly. So if I have a diameter of 6, then my pitch is 1. If it's 8, it's 1.25. If it's 10, it's 1.5, and the rest is pretty much generic. I want my major thread diameter to be the same as my recognition diameter. I want the thread rotation to be right, or I could make it, if I want that, I could make it a left, but I want that a right rotation thread. I have the thread length specified, and my tap drill size is basically equal to my recognized diameter minus my pitch, right? I can save that, and obviously this is an admin job. Not everybody can figure this out, but if I now go back and run my feature find command again, my find features command again, it will take a slightly longer because it was reading my XML file. And you'll now see that my map feature is sensitive. If I click it, I get the extra option of recognizing step 1 hole threads. That's because of the mapping rule that I just added. If I would now do the recognition, you'll basically see that I still have my 2 pockets, I still have my regular step 1 hole, and I now have my step 1 hole thread, because that was a yellow hole, and as a result, if I now use my create feature process and use the standard knowledge, hopefully this hole is no longer drilled, but it's being tapped and tapped as well. So running that through. Go back, there we go. It's now being spot drilled, and tapped with the proper data. And so that is one first use case for the machining knowledge editor. I'll delete the information, and you've seen how. And if I switch it back off again, what I'll do, hopefully find the 2 features again. We'll take it to the next example. Where we'll just look at the 2 holes. So it's no longer a threaded hole. I didn't use the mapping rule anymore. It's back to a regular hole, and I'm just going to look at the out-of-the-box results, and going to make some changes there, because you might be happy that you get a result, but you might be disappointed with the type of result because you work quite differently. So let's have a quick look. I did the 2 features, and if I make the window slightly smaller, move the part up a little bit, right? You'll see, as I mentioned before, both holes being spot drilled, and the larger hole being spot drilled, and finally drilled a little bit bigger. And I can now actually go and look at my information window, and for my feature, I can go find the related results. So that was feature 3, as we saw here. The result is a spot drill and a drill in center. And what you have to know is that basically the create feature process runs backwards. It first finds the last operation, in this case the drill-in center. And when it's done with that, then it will find the previous operation. So it always works backwards. It's something to get used to. And if you read this information window, you will see that it tries a couple of rules, and they all fail for some reasons. And finally, one rule is successful, and another rule is successful, and that's the process we get. Now, let's go and make some changes into this default process. The first thing that I notice is that in the out-of-the-box, we're used to do spot drilling operations for everything. And the very first rule that we were trying is called drill S1H, and that would just drill it without doing any spot drilling. And the reason why that rule was ignored was because there was a constant that indicates spot drilling is required. So let's go and change that. So I'm no longer in my mapping area. I'm going to my machining knowledge. I'm going to my my libraries. I'm going to my mill drill, and now, oh, there's a whole lot of them. What do I do? Where do I start changing them? The best way to browse through all these rules is to basically take a note and say activate the children. That puts all the rules in sort of an Excel-like view. I could go sort and search for it, or I could use Excel-style auto-filtering. I could say, well, give me a rule, give me all the rules that produce a step 1 hole, as those operations we're doing, and give me all the rules that also use a twist drill. And now I've only got a few of them left, and one of them being this drill S1H that I was looking at. And whenever I look at a rule, it basically comes with a few pieces of information. It comes with conditions, it comes with constants. The rule can be applicable to all materials, as we have in the out-of-the-box, or I could make this rule specific for some materials. It can be for all machines or for some machines. And obviously, those of you familiar with NX will see, hey, this is the out-of-the-box set of materials and machines. How about the machining knowledge editor using our own materials and machines? We'll talk about that later. It will contain explanation on the rules. It can contain an image. So if I look at one of the others, right, there's a lot of explanation in there. There could be an image in there that shows exactly what this rule does. And each rule basically is a transition of some input geometry, in this case a pocket round tapered as a start geometry. It's using a twist drill, and it's producing a step 1 hole feature. So input feature, output feature, the tool that it's going to use, and the template that we're going to instantiate. And one of the first things I could go do now is maybe change to a different tool. I would hit F8, and I would see, just like in NX, I would see all the different tool types. So instead of a twist drill, I could make this an indexable insert drill, or just an insert drill, right? Whatever I want. I'm not going to change it. I'm just showing you what you can do. The same is true for the operation class, or the templates. Hitting F8, I could see all the different types of drilling and milling operations, templates that I have. This is using the drilling template from the machining knowledge template file. I could use brick chip drilling, I could use boring, whatever I have in my templates, right? Not just out-of-the-box templates, but your own as well. So I'll just leave that to what was I using drilling, right? So that gives you the high-level idea. The first thing I wanted to do was make sure that this rule was actually used, drilling it without doing any spot drilling. And that condition failed because there was a constant saying I should always spot drill. Now, constants are things that we define not in a single rule but across rules. Now, the rule has rule-specific constants, and there are none of them there. Or I could go to the library level and look at the constants there, and there are a lot of them, right? There are all sorts of constants, different types. We have them in different unit systems, so we'll talk about that later. And one of the constants, the first constant I want to change is this Boolean. It says, use spot drill, yes or no. 1 is yes, 0 is no. So if I put a 0 in, I save this, I go back to NX, and delete my previous results. Go back to my features, run it again, and running it through, you will hopefully see in a minute that, hey, I'm no longer doing any spot drilling. So that hole is drilled, that hole is drilled and drilled a little bit bigger. So with a single change, I was able to make an impact. Now, the next thing that I'm looking at is, and I want to change that as well, is this operation, drill up S1H, right? If I look at the operation, it's actually using a 16 millimeter tool, I think, right? It's a 16 millimeter hole, and it's pre-drilling it. So maybe if I look at the material, this is aluminum, okay? So maybe you're saying, well, why would you pre-drill 16 millimeters with probably a 10 millimeter hole? I can drill 16 millimeters in a single operation. I don't need the pre-drilling and then drilling it up. So let's go make that change as well. And it's actually in the same constants. I can go look at the conditions and see where that is being used, and go find that. It's basically saying the diameter has to be larger than a certain constant, and that constant is called pre-drill limit. And if that's the case, then I'm going to pre-drill it. So what's the value of that constant? There we go. There it is. It's 12 in millimeters, and if I would change to inch, it's probably half an inch, right? So let's go back to the millimeter version. I can now go change that pre-drill limit from 12 to, let's say, 20. But instead of me doing that, as you've seen me do before, I'm going to do something slightly different. I'm going to say, well, this is actually dependent on the material. So to the right here, I have a complete table where for this constant, I can put in a different value for any combination of part material and machine. And in this case, I don't care about the machine, but I'm basically saying, hey, aluminum, anything goes up to 20 millimeters, right? And just to show the difference, if I have stainless steel, maybe anything above 8, I want to pre-drill, right? So I've kept the standard value of my constant, 12 millimeters, and I've given it a different value depending on the different part material. Saving the change, going back to NX, deleting my previous results, going back to my two features, and remember, my workpiece was aluminum, right? It's aluminum, so what would you expect? Hopefully, since I said I can drill 20 millimeters without pre-drilling in aluminum, I'm hoping that I just get two operations or a single operation per hole that will just drill it. That's what I hope. Let's see, and that's where we are, right? Exactly what I need. And if I just go back and now change the material to a stainless steel, run it again, Now basically both operations should be big enough. They're both larger than 8, so both need to be pre-drilled. And if I would change it back to copper, one of them would be drilled in a single operation, the other one would be drilled or pre-drilled and drilled. Yeah. So the constant mechanism is a way to change out-of-the-box stuff without really defining any new rules. And it's pretty quick and pretty simple. The last thing I want to do is quickly show you how I could generate a completely new rule for a standard feature. And I'll do that in the tech tip rules library that we used last week. Right? In last week's sessions, we did some operation teaching and we created those rules from NX automatically. Now let me create a new one, a machining rule. I'll call that my pockets rule, and that's basically gonna machine a pocket. You see all the feature types. Pocket rectangular straight. I don't need any pre-machining operations. I'm going to look at my my tools. I'm going to say I'm going to use an end mill non-indexable. And what's the template I'm going to use? I'm going to use a volume-based floor wall milling, new in NX85. I have them in multiple files. I can take them from the machining knowledge template. I can take them from the mill feature, or I can taking them from the mill planner. That's fine. And then I typically start with adding conditions on my tool. So if I want to machine that pocket, then I need to put some tool conditions. Maybe my tool diameter, let's start with that, should be larger or equal to 2.0 times the feature radius. And maybe my tool flute length should be larger than my feature depth. Maybe the last thing I want to do is my corner radius should be equal to my feature bottom radius. Some very simple conditions on the tool, and now for any size of pocket, I will find an appropriate tool. Let's save that. Go back to my NX session, and I'll just use this single pocket. Use the create feature process. Now I'm not going to use the out of the box, as you saw me do that before, but I wanted to use my own rule. So instead of using the mill drill, I'm going to use the tech tip rules library. Everything else is going to be the same. And hopefully it will pick my rule. It did something, so let's have a look. Yep, it picked my pocket rule. So it knows what the geometry is that we need to machine. It actually picked a tool that has a very large diameter, so I obviously made a mistake there. And that's something I need to correct. I've just been asked to finish up because I need to leave the room. Basically, one last thing I want to show you is that, and that's my mistake, I said that the tool diameter should be larger than the corner radius. Obviously, it has to be smaller than the corner radius, so we'll fix that. The last thing I want to do is just show you that basically the operation came, if I go back to the NX session quickly, the operation came exactly as it was in the template, right? It had the exact cut pattern, it had no depth per cut, it had a blank floor thickness, everything just as it would come from the template. And I want to make a few small changes to the template, showing you how that works. So maybe my region cut method should be follow part, and maybe my operation blank thickness should be equal to my feature depth. And maybe the very last thing I want to do is I want to add a depth of cut, but I'm going to do that as an add-on, as an operation parameter that is determined at the end of the operation selection. And I'm going to say my operation depth of cut is going to be depending on the tool. So it's going to be my tool diameter, maybe divided by 4, 25% of my tool diameter. This type of conditions I really want to do at the end of the whole process, which is why they're done in the add-on. So that's my last change to the operation. Going back to NX one final time, deleting my results, and creating the process one more time. I should now hopefully have produced a good tool, selected a good tool, and changed a few settings on the operation. That could be dependent on whatever I want to do. So I'm done. There's my operation. Let's quickly check the tool. I fixed that. Now it's a 16 mil tool. That fits. I have my follow part cut method. I have my floor thickness of 10 millimeters, which is the depth of the bucket. And I have a 4 millimeter depth of cut, which is 25% of my tool diameter. So with that, I can now go and recognize my tool path, generate my tool path, and I'm done. So with that, let's go back to the last slides of a summary. The point that's important to make is that the XML file that NX is using is configured in your CAM configuration. If you know camgeneral.dat, then there's a reference to the machining knowledge in there. You can use whichever machining knowledge file you want to use. You can manage it in Teamcenter, or you can manage it on the file system. Using a different configuration allows you to use different tool libraries, like the MRL, the Manufacturing Resource Library. It allows you to use your operation templates, your own machines, materials, cycles, user-defined events, and so on and so forth. So there's a lot more configurable than I've just shown you. And I want to leave you with this last comment on the Machining Knowledge Editor. It comes with a lot of extra information, and that is go to the help and the help topics from the Machining Knowledge Editor, and that will bring up a large PDF with additional details. With that, I want to conclude this session and open it up for questions. Derek, back to you.
So thanks, Tom. It's been a terrific 3 weeks. I know we're enthused to see what custom features we can include in our individual shops' feature automation schemes. I think it's very clear now how much flexibility is available for feature and process customization using the Machining Knowledge Editor. As always, the conversation will continue at our discussion forum, where you'll find all the Tech Tip recordings, as well as the questions that come out of these sessions. I encourage you to use the forum to replay these Tech Tips and to continue to ask questions and add your comments.